Hey guys, we're going to look at how to factor trinomials today. So in this lesson, you will learn how to take something that is a trinomial, so remember that's a polynomial with 3 terms, and break it into smaller factors or into 2 factors using what we call the bottoms up method. So I can break trinomials, that's our goal today. Let me get this working right. I can break trinomials into 2 factors, or into factors, we'll just say factors, using the bottoms up method. So this, for some people, is a little bit fun because it's kind of like a puzzle. But for other people, they have a hard time with it, especially if you have a hard time with multiplication facts. So you may have to make like a list of factors sometimes for these problems. But overall, the process here is not terrible. So let's take a look at what this actually means. So the bottoms up method is used with trinomials. So remember, a trinomial is a polynomial with 3 terms, 1, 2, 3. Typically has an x squared term in it, and then a plain x, and then a constant. Before you do anything else with factoring a trinomial, you want to look and see if there's a GCF. If there is one, before you try to factor it, you need to factor that GCF out first. For example, if all 3 of your terms are even, then they're all divisible by 2. You need to divide them all by 2, factor a 2 out before you try to continue to factor the rest of it. Otherwise, you're not going to have a complete factorization there. Then, once you have done that, you're going to multiply your A times your C. So this is your A, this is your C. So you take those 2 outside terms and you multiply them. That's what I'm going to call your magic number. So you get your magic number, whatever that is, when you multiply those 2 terms together. Then, this is where the puzzle part comes in. You've got to think about 2 numbers that you could multiply. That you can add to get your B. That you could also multiply to get the magic number. Okay, so that's like if you had, I don't know if I can think of one of these off the top of my head. But let's say your A was 1 and your C was 4. And your B value was 4. So your magic number would be what you get when you do 1 times 4. This 1 times this 4. Oops, that's not working. This 1 times this 4 gives you a magic number of 4. So you'd have to think, what can I multiply to get 4 that I can also add to get this 4 down here? And so you would think, okay, 2 times 2, because 2 times 2 gives 4. So then you divide both numbers by your A. And write it as 2 factors. So your factors will be x plus one of those numbers and x plus another number. Or it could be minus. Let's call it plus or minus one number and x plus or minus the other. Because depending on whether your number is positive or negative, you're going to write it the other way. So x plus or minus one of those numbers, x plus or minus the other. And then, if either factor contains a fraction, after you do that division, if either factor contains the fraction, we're going to do what's called bottoms up, where we move the bottom of the fraction to become the coefficient for the x. And I'm just going to show you what that means down here. I'm not going to work an entire problem out, but let's say you get to that step of you have your 2 factors and you have to divide both numbers by a certain number. So let's say you end up with x plus 3 over 2 as one of your factors and x plus 4 as the other. I'm just making this up, okay? So if those were your 2 factors, this factor right here can't be left like this. You cannot leave factors in fraction form. Factors are whole number values that can go there. So we would do what we call bottoms up with just that one. We would take, and usually it's just one that ends up like this anyway. we would take what's on the bottom, so the 2, and we would move it up to the front of the x. So instead of writing that factor as x plus 3 over 2, we would write it as 2x plus 3. So the 3 still stays in the back of the factor. The 2 from the bottom moves up to the front. And the x plus 4 would still be just x plus 4. That would be the second factor. So that's the bottoms up method. That's what they're talking about there when we say to do bottoms up. So let's get into some examples of this, because the more we practice, the better this gets for us. Take a look. So I've got some examples on this slide that have just 1 as the coefficient in the A position. So that's going to make this a little bit easier because we're not going to really have to divide, but we'll look at what that looks like. So remember, trinomials have to be in the form ax squared. Why is this not doing what I want it to do? Plus bx plus c. Now, it could be subtraction in there in different places and stuff. To be able to do factoring with it. So if it's not already in that form, you want to rearrange it so that it is. Most of the time, they're going to give them to you in that form already. So with that, I'm going to take my a from my example here and my c. So that's going to be 1 and negative 12. And I'm going to multiply them to create what I'm calling my magic number. So 1 times negative 12 is negative 12. That's our magic number. So I have to figure out, to be able to solve this, 2 numbers that would multiply to give negative 12, that would add to give 4, because 4 is my b. So I'm looking at numbers that will multiply to give my magic number, that will add to give my b. So to do that, I've got to, especially when it's a negative number, I've got to really think about that, because when you're multiplying to get a negative, one number is going to have to be positive and one number is going to have to be negative to make that happen. So what are ways we can multiply to get 12? And if you're not good at just kind of thinking through this on your own, it might be very helpful to you to make a list. So I know 1 times 12 is 12. I know 2 times 6 is 12. And I know 3 times 4 is 12. Those are the only ways to multiply and get 12. So because I need it to be negative 12, I know one of those numbers is going to have to be negative. So thinking about that, if I want to end up with a positive 4, I need to keep my bigger number positive and my smaller number negative and see which one's going to do this. So, because I need to be able to add them and get a positive number. So looking at that, which of those pairs of numbers would add together to give negative 4? This one, negative or positive 4. Negative 2 plus positive 6 is positive 4. And negative 2 times positive 6 is negative 12. So that's my pair that works here. So I'm going to take that, and I'm going to create 2 factors from it. Now, I would divide them both by 1, because 1 is my a. Negative 2 divided by 1, 6 divided by 1. But, of course, that's going to stay the same. So we don't actually have to do that step of division when there's not a coefficient. But it's good to get in the practice of it. So that means my 2 factors, well, I don't know what I did there, are going to be always an n in the front, or whatever your letter is in the front. So n minus 2, because one of them is negative 2, and n plus 6, because one of them is positive 6. Those are my 2 factors. Now, if I wanted to check this in Desmos to see if I was right, I could go and type my original problem in and type my 2 factors in, and as long as it creates the same equation or the same graph, I'll know that I've done that correctly. If it doesn't, then I have made a mistake some kind of way. All right, let's do another one. This one will be a little easier because it doesn't start with a negative. So 1 times 64 is 64. So 64 is my magic number. I've got to think of ways I can multiply and get 64, that I can add and get 16. Now, some of y'all immediately know that 8 times 8 is 64 and 8 plus 8 is 16. And you get that, and that's great. If you don't see that right away, you can always go and make a list. 1 times 64, 2 times 32, 3 won't go, 4 times 17, nope, 16, 5 won't go, 6 won't go, 7 won't go, 8 times 8. So there would be my list. The only group of these, and everything can stay positive this time because I have a positive number I multiplied to get, have a positive number I'm trying to get here. So 2 positives will give me what I need here. So the only pair of those that would add to give 16 is the 8 and the 8. So I would divide them both by 1 because there's a 1 in my position of A. So 8 divided by 1, 8 divided by 1 is still going to be 8. And so my two factors are B plus 8 times B plus 8. That's my answer. All right, another one. So 1 times negative 24 gives me my magic number here. So I need two numbers I can multiply to get negative 24 that will add to give me 2. So again, I'm going to have a negative and a positive because the only way to multiply and get a negative number is to have one of each. So I can do 1 times 24, 2 times 12, 3 times 8, 4 times 6. Those are all the ways I can multiply to get 24. 5 won't make it. So if I need to end up with a positive 2 in the middle, I need my bigger number to be positive. So I'm going to test this out with negatives in the front. Looking at those pairs of numbers, the two that will combine to give me a positive 2 if I add them are these two. Negative 4 plus 6 is 2. Negative 4 times 6 is 24. So to make my factors, I divide them both by my A, which is 1, which means they'll stay the same, and I'll end up with M minus 4 and M plus 6. All right, we'll do one more like this, and then we'll look at some in a minute with some numbers in the front. So the next one, 1 times 24 is 24. So I need to multiply and get a positive 24, but add and get a negative 4. That's a little bit tricky. Because to multiply and get a positive, but add to get a negative, we would actually need two negative numbers. So we've got to think, so negative 1 times negative 24, negative 2 times negative 12, negative 3 times negative 8, negative 4 times negative 6, and that's it. So looking at this, if I added those together, negative 1 plus negative 24 is negative 25. Negative 2 and negative 12 make negative 14. Negative 3 plus negative 8 makes negative 11. Negative 4 plus negative 6 would make negative 10. None of those pairs that would multiply and give 24 can add and get negative 4. It's not possible. So this is not factorable. And that happens sometimes. Sometimes there's not a way to factor it, and that's okay. All right, continuing along. Now let's look at some that have numbers in the front. So if there are numbers in front of your first term, the first thing you want to look for is there a GCF that you can factor out? Okay, so we look for a GCF. In this first one, I've got a 3, a 2, and a 5. There's not a number that will evenly go into all three of those because 3 and 2 and 5 are all prime. So I don't have to worry about factoring something out to start this problem. So I'm going to multiply to make my magic number. 3 times negative 5 is negative 15. Whoa. Negative 15. So I've got to come up with a way that I can multiply to get negative 15, that I can add to get negative 2. Again, to multiply and get a negative number, I've got to have one positive and one negative. So think about the ways we can do this. 1 times 15 will give 15. 2 won't. 3 times 5 will give 15. If I want to end up adding and getting a negative number, I need to test these with the bigger number being negative. Because if I add two numbers together, the bigger one is negative, I'll end up with a negative answer. So the two of those that will give me a negative 2 when I add them together are 3 and negative 5. Now this one, we've got a number in the front, so we're going to have to divide both of them by that number. So divide by 3, divide by 3. So I'm dividing by the A. 3 divided by 3 will give me 1. Negative 5 divided by 3 is negative 5 over 3. So this is one of those situations where we had to change our factors by dividing by that front number. Now we can write them. So P plus 1, because it's positive 1. Now the second factor is a fraction, so I'm going to move the bottom to the front, make it 3P minus 5. All right, let's look at the next one. So 2, 11, and 5 don't have any common factors again because they're all prime. So I'm going to multiply and get my magic number, 10. So I need a way I can multiply to get a positive 10 that I can add to get 11. And almost always, if they're one number apart like that, it's going to be 1 times the original number, because 1 times 10 is 11. But you could try other ways if you needed to, 2 times 5. Okay, so those are the ways we can make 10. The only one of those that come together to make 11 when you add them is the 1 and the 10. So if those are the two factors I'm going to use, I'm going to take them both, divide them by my a, which is 2, and that's going to give me 1/2 and 5. So my two factors will be v plus 5, and then for the one that's a fraction, I've got to move the bottom to the front, 2v plus 1. And I'm using plus here because they're both positive numbers. I used minus in this one because this was a negative number, so I had to have a minus in that one. Now, the next one is 9, 66, and 21. All three of those numbers are divisible by 3. I can look at that and I know that. So before I start this, I'm going to factor a 3 out. And that's going to leave me with 3k squared plus 22k plus 7. Okay? So then I'm going to multiply and get my magic number, 21. And again, I need ways that I can multiply and get 21 that I can add and get 22. Same situation we had before where they're one number apart. So I know 1 times 21 will multiply to give 21 and add to give 22. So divide both of those by 3. And my factors are 1/3 and 7. So the 3 we factored out at the beginning comes down as part of our answer. And I'm still going to write my two factors. So k plus 7. And then the 3 from the 1/3 goes to the front because we got to go bottoms up. 3k plus 1. This is your final answer. Be careful if you have one that has a GCF. Make sure you put the GCF in your answer for your factorization. Otherwise, it'll be wrong. And then the last one, 2, 3, and 9 don't have any common factors because 2 and 3 are both prime. So I'm going to multiply 9, or negative 9 times 2 is negative 18. So I need ways I can multiply to get negative 18 that I can add to get 3. Since I'm multiplying to get a negative, I know one of these is going to have to be negative. But 1 times 18, 2 times 9, or 3 times 6. That's the ways I can multiply and get 18. 4 won't go and 5 won't go. And then it'll be back to 6 again. So if these are the ways that I can do this, and I want to make a negative 18 but add to get a positive number, I'm going to let my smaller numbers be negative so that when I add them together, I end up positive. And so the only way that would come together to give me a positive 3 would be, oops, that was not the highlighter, that was an eraser, would be negative 3 and 6. So those are the two I'm going to use. Divide them both by our A. Divide by 2, divide by 2. Sorry, my phone's ringing. And so that gives me negative 3 over 2 and positive 3. So my factors are n plus 3 and 2n minus 3, because I did bottoms up there. Move the 2 from the bottom up to the front. Right. Many interruptions. Sorry. Okay, so 2n minus 3. I was trying to make that so we could see it like that. Okay, that's our factorization for that one. All right, keep rolling. So take a minute, pause this, and see if you can factor these out, just like what we just did. So find your magic number, find two factors that will create your magic number and add to make your middle number, and then write those factors out. If you have a fraction factor, do bottoms up with it before you show it. So pause the video, try those out, and then come back and see if you were correct. Okay, so if you multiply those and you find your factors, you see that 7 times 8 will give you a negative 1 when you add them together, and a negative 56 when you multiply them if you make the 8 part of that negative. So, okay, so take a look at this and see if you got the same things that I got. with it. So for the first one, your magic number was negative 56. So a negative 8 times a positive 7 would give you that, but also add to give you negative 1, which is what your middle number is. And so those were your factors. You divide them both by 1, and they stay exactly the same. The one underneath it was really the same way. You multiply to get negative 90. Okay, so the next one, to add to get a 1, but multiply to get a negative 90. Again, we had to have one that was positive, one that was negative. So a positive 10 with a negative 9 would create that. And so again, you divide them both by 1, and they stayed exactly the same. Now, the next one, your magic number was 60, but you had to add to get 19. So a positive 4 with a positive 15 would do that. But you had to divide them both by 5, which actually changed your values into 4 over 5 and into 3. So I kept 3. I did bottoms up with 4/5. And so these became my solutions there. And kind of the same situation for the last one. You have to multiply to get 12, positive 12, but add to get negative 8. So you needed 2 negative numbers for that. And a negative 2 times a negative 6 would have done that. So bottoms up with that again, because you had to divide by 3. And you end up with negative 2 and 3n minus 2 as your 2 factors for that. This is one of those things that it really just takes a lot of practice to get good at it. So if you're struggling with it at this moment, give yourself some time. Hopefully it will get better for you. So we're going to stop right there for today and let you guys do some practice with this to see if you can come up with the factors for some trinomials like this. So the rest of your time today will be spent working through that. And then when we come back together on Monday, I'll go back over some of this with you guys and then show you one final way of factoring before we start kind of practicing with all the different ways together. And then hopefully by the end of all that, we'll feel pretty good about factoring in general. So we'll stop right there. Y'all make sure you submit what you have, and then we'll pick it back up again on Monday when I return. Thanks. Y'all have a great day.